Hi, I'm David. I do a lot of work with Pantheon and Drupal, and this is actually 10 years since I've given my first talk on proxy caching for Drupal. The first one I gave was in Boston in 2008. It was my first DrupalCon. Back then, squid was one of the things that we talked about. There won't be any squid in this presentation, but these techniques are alive and well, and I think that they're even more relevant today as people decouple their applications. So the topic today is effective API caching, achieving high hit rates when your client is a decoupled front end. This isn't just for decoupled front ends. You could use this for other decoupled architectures as well, but the examples are focused on front end use cases. So before we get into the bulk of it, I'd like to know how many people here are using at least a proxy cache or CDN for the front end of your site. Okay, this is the biggest difference from 10 years ago. Everyone's doing this now. So everyone is using Cloudflare, Varnish, Fastleaf, CloudFront, Akamai, you name it, in front of the site, putting it between the browser and at least the most initial part of your kind of backend services, including front-end servers. And this is great, and I think this is more important than ever, and I have tons of talks I've given on this topic of why this is super important for HTTPS and all sorts of other performance cases. And but I'll just say, if you're not already doing this, this is probably one of the first things I'd do. While none of the architectural diagrams will include this element, this is sort of assumed to exist in your setup. And this is kind of what that basically old traditional style is. And there are tons of sites that still use this. There's nothing wrong with it, but it's not decoupled. And once we start decoupling this architecture, we start having a lot more communication between different parts of our backend resources. So I'm kind of curious to hear more about use cases in this space from people, and the particular ones that I've been focusing on are security, personalization, and geographically distributed dynamic users. I don't want to open the floor up yet, but I would like to have some time for questions at the end. So if you have use cases that I'm not covering here, this is my first time giving this presentation, and I made it just for this conference. So if I'm interested in hearing people's different needs. In terms of these use cases, for security, one thing I mean here is that Drupal's a complex application, and by decoupling a front end from Drupal, we can basically isolate it away from a lot of the initial attack vectors on the web. Personalization is where maybe you don't want to just live in the two traditional realms of Drupal where you have authenticated users getting totally custom pages and lots of backend and database traffic, or just totally static cached pages, and maybe you have a middle ground use case. This is almost kind of the Facebook style of architecture where they need to generate tons and tons of custom pages based on personalized data, and they can't do that by going back to every single backend service every single time. And so perhaps you use decoupled front end to personalize your content so you can deliver dynamic pages to different users without fully bootstrapping Drupal every time. Another use case is geo-distributed dynamic users, where perhaps you serve users throughout the world and they need to be able to log into the site, and you need to be able to serve them content and provide them a great experience. And these are the three that I've focused on for this presentation. So why not an object cache the front end? And I understand that this is probably not a question that all of you are actually even asking, because I understand it's common to use Varnish and other reverse proxy caches between the front end and back end for a decoupled instance. But in case you are new to these sorts of architectures, one of the things that, if you're coming from the Drupal world and you're thinking about caching objects, you might think about caching it away by adding, say, memcache or Redis, and then accessing that from the front end or the back end. I'd like to caution against some of these architectures because they are actually really complicated to maintain from a coherency perspective. The let's say you have caches for the front end. Let's say you have a Node app that is talking to memcache and caching objects in there so that you don't have to invoke Drupal's APIs every time you need an object. That works well, but it means that Drupal actually would need to understand how to invalidate things in the front end's memcache instance. And now you have all the backends and all the front end instances all having to talk to the same cache, and you have possible coherency issues here where if the front end changes the way it caches content in, say, memcache, and the backend doesn't get updated in a completely corresponding way, you could have incoherency here and stale content or confusing experiences for users. Contrary to that, another approach you might think would be an initial one coming from just a pure Drupal background is to enable more of the object caching in Drupal and adding in things like Redis or memcache to Drupal. And you probably should consider doing that anyway, but using that as your main cache for your systems would require bootstrapping Drupal for every single one of these requests. And that is actually putting a huge amount of burden on the performance of your application. So I don't think either of these approaches are particularly compelling. So I typically advocate for using reverse proxies for API caches. This is an architecture that we use at Pantheon with several sites. One of them is a top 100 site, patch.com, and they have both a CDN in front of their front end that actually is between their end users and their website, as well as a proxy cache between their front-end instance and back-end instance. In their case, they're actually using Drupal for both the front-end and the decoupled back-end. But you could swap in any technology that you wanted in these places. The way that this works as an architecture is that you end up with a reverse proxy. How many people are familiar with the term reverse proxy? Okay, great. Okay, so one of the challenges here is setting up the invalidations from the web application. In this case, at least you have an application that understands the patterns that it's invalidating, that Drupal is both producing the content at the right URLs, and it knows what content is at those URLs, and it's therefore able to invalidate the content at those URLs. And so it doesn't have to deal with any sort of disconnect here in this architecture between the assumptions of the front end and the assumptions of the back end, because the back end is both populating a cache like Varnish as well as managing it. And a large chunk of what we'll be talking about is how to manage these invalidation patterns. Because how many people here, so I noticed that many of you have, you're familiar with reverse proxy caches. How many of you run a reverse proxy cache between your front end and back end? Okay, so that's about 5 to 10% of people in the room. This is one of the first things I'd throw in. Even if you don't explicitly invalidate things in your proxy cache, I would consider doing at least a short duration cache there. Even storing things for a few seconds in Varnish can actually have quite an impact on the performance of your application if you're making multiple API requests from the front end back to that back end. If you're fetching multiple pieces of content, and some of them are used on almost every page, even caching things for 10 seconds in Varnish can dramatically speed up your application. But if we really want to get hit rates high, we can't just cache things for a short term in the proxy. We actually have to be able to let things be there for a while, and we need to be able to flush them out and purge them when we actually change things on the site. So if you edit a node in Drupal, how do you know that what's being requested from the front end is actually changing in the cache, and not just by waiting for it to change on that stale content? The most obvious way to do this is using something like just invalidating by the URL, but that's also not a great way to keep content for a really long time, because if you have content that is in your API responses, and any of your API responses source content from different parts of your application, like maybe you have an API request that returns 3 nodes, or maybe a view or something like that, keeping up with the invalidations can be really hard because there's not a direct one-to-one correspondence all the time between backend data objects and the actual API responses that contain them. So indexing and invalidation for your API's proxy is a great way to actually manage this content and manage the ingredients that are going into the page. So I'm going to provide these examples based on open source Varnish. All of these are applicable to almost every CDN and other modern proxy cache that you can have, but I just wanted to use something that anyone could throw onto a virtual machine. So how many people are familiar with Drupal 8's cache tag system? Okay, that's awesome. So that's a great advancement in core in the sense that we're now able to actually identify an ingredient list that is going into each cache item. And the reason I like to call them ingredient lists is because I almost think of them like putting a product on a shelf. And if you were a company and you made cans of soup and you put them on a shelf and you realized that you had labeled them as like you had put the list of ingredients in there and you realized that one of the ingredients that you had put in those products was tainted and you needed to pull them off the shelf, it would be really useful to be able to know exactly what products to pull off the shelf because they contain, I don't know, kale or peanuts or some other thing that you might need to.
Kale's never poisonous.
There have actually been a lot of E. coli contamination issues with leafy greens. At least regionally. It's usually it's not from the kale itself, obviously, but it's from runoff from other things. But in any case, instead of the worst case is you would have to basically flush all the products out of a store, and that's actually kind of equivalent to flushing your entire cache anytime something changes. But by providing an ingredient list, we can actually selectively invalidate. And this is key to high cache hit rates because we basically want to keep the cache as populated as possible, as hot as possible, but we also don't want things to go stale in it. So the way that Varnish, at least Varnish v4 and v5 can support this is by using a module that you can install that supports something called xkey. This has many equivalents in other systems. Basically, every major enterprise CDN product or proxy has an equivalent of this. All of these are almost exactly equivalent. About the only differences between all of these headers in terms of how they behave is that some of them use spaces between the tags and some of them use commas. And that's about the end of the differences. Yes?
And the limits.
Oh yes, there are different limits on these things. For example, in Fastly, there are different limits on the character sizes for your headers. And in the implementation we have on, say, Pantheon, we actually have some limits on the number of tags you can put on a given item. These caps can be pretty high, and if you're manually managing an API, I don't think you're that likely to run into them. But if you do something like just take all of the Drupal cache tags and put them into this, which is something that we often do for sites on Pantheon with the advanced page cache module, which you can also kind of browse around the implementation of if you're kind of curious how it all works to like harvest the cache tags out of Drupal and put them into one of these headers. But if you're manually doing it, don't worry too much about the limits, but if you're using the Drupal tags, that can easily get unwieldy, and we've seen cases where someone pulls up a view and there are so many tags on the response for the view, or even just like the API result from a view, that it can overwhelm some of these. So just be wary of that, because one case, often what these will do if you run over the limit is they'll just ignore further tags on the item and you'll end up with stale data. So that's an important point. So in this case here, something like xkey would generally have a whole litany of things on it. It's not usually just going to be one thing, but for the purpose of this example, let's say you're delivering a page that just contains node 1. By putting an xkey into the response back from the Drupal instance and passing through the proxy, this is now providing the proxy with something that it can actually read and understand about the content in that response. It doesn't understand any of the JSON you're sending. It doesn't understand any of the other kind of protocols or formats you might use, like XML or stuff like that. But this is actually something legible to it. It's an ingredient list it can read. And if you are running something like just open source Varnish and a module for it, you often have to do a little bit of extra tweaking to your configuration on something like Varnish to enable purging of these keys. It's not something that usually is supported out from remote APIs out of the box. you're going to want to put some security around this. This example doesn't have any kind of permissions check, but generally you want to whitelist it for IP addresses or require some other authorization header. The different ways people authorize it are variant enough that I didn't want to put anything, too much assumption in here. CDNs typically have an API for this, and they'll basically provide you in their API documentation the way that you invalidate a cache tag or cache key or secondary index. And then it's actually pretty simple once you actually have it. Let's say you want to basically recall everything off the shelf that has these ingredients in it. Some of these APIs support doing multiple ones. This setup example that I just did allows doing one at a time. So if you had multiple nodes that you were saving all at once, you would have to make multiple requests to purge them. But the thing that's really neat about this is that this is not actually literally purging one thing out of the cache. It's purging everything that actually had that ingredient listed on it. This means whether, in the traditional case, if you were delivering a full web page from Drupal, this would eliminate any page. This would purge any page out of the cache that had, say, a block with Node 1 content on it. Or in the case of if you're doing API responses for, say, sort of views results, you might have something where you can purge any view that actually had Node 1 content in it in the response without having to track any of this on your side. You can just basically say that something about Node 1 has changed. There are various ways to purge as well. There's usually a concept of hard versus soft purging in these systems. A hard purge is considered to be a forceful flush of those items out of the cache where you absolutely do not want them used at any point following the purge of the item. I generally discourage that unless you're working with something extremely sensitive where you can't have even the smallest amount of stale data. Usually what I encourage looking at is something called soft purging. Most APIs support this. The idea of a soft purge is basically that it sets the time to live of the existing item down to 0, but is willing to use it in the tiny interim before it actually gets a fresh copy. And the advantage of the soft purging thing is that all of the API requests that are cached that contain the now changed object will continue to serve these slightly stale data until it's replaced, which means that you never have a stampede on the back end. You never have slow responses back to end users because you're using your cached objects even if they're microscopically stale. That's supported in most systems. So, in the case of open source Varnish, you need, I believe, a second module now to support the soft purging. The other thing that's important to handle with these in terms of getting high hit rates is to make sure that the data is properly segmented so that you don't have to have lots of cache responses that bypass the cache. Because one thing that you might think is that if you have the same URL and you have different content on it, you might assume that because you're personalizing the result for each user or each language or other things, that you wouldn't be able to cache it in this sort of proxy. But there are some great techniques around that. And these are actually really neat things to learn also for front-end proxy caching, where you're actually dealing with web browsers as well. But the fun thing about doing a proxy between your front-end instance and decoupled backend is that you can actually use whatever arbitrary headers and behavior you want with this sort of thing, because since you run the client and you run the server, you can actually set up neat behavioral patterns between them. So I've tried to figure out a way to kind of explain this, because it's actually a really abstruse concept, the way that a lot of the vary headers and things work. So the closest I've come up with, and I'd love feedback for this after from people to see if this kind of gels, is the idea of almost having like a permit office at a city, where you basically have at a permit office this idea that you have a client that is basically requesting a permit to do a project, and then the permit office is deciding whether to approve the project or not on the basis of the application. So typically, and this is the case in most cities, especially where I live in San Francisco, that it's opaque and it actually doesn't have a lot of feedback here. And this is basically like a very naive implementation of here. This is the idea of like, let's say I wanted to request something that is based on having a 1-bedroom apartment, 70 square meters, no lead paint, and 1 floor. And this project, let's say, meets the approval criteria. But all the backend, all this proxy cache gets to see from the backend is this sort of response here. They basically get to see that it was approved, but they don't get to know why. And they don't know what criteria could possibly approve or reject it. And part of why I like to use the example of a permit office is, let's say you had people working at the front of the office that weren't qualified to review all of the applications or all of them in detail, but might be able to do some rejections or acceptances on the basis of some narrow criteria. And this is basically like as if the people working at the front of the office are sort of a proxy cache for the way that the permit process works. But now, let's say you submit one where, let me fix this slide. There we go. Let's say you submitted an application for building an apartment with all the same criteria, except you decided to try and use lead paint on it. Obviously, this is going to get rejected by a permit office because it's not compliant with any of the building codes. In this case, it's still opaque. If I have a proxy here, it wouldn't know anything more about the rules for permits than it did before, because I've basically told it that I'm rejecting it, but I'm not telling it why. But HTTP actually has an answer for this. Let me fix this one again. And then I'll click the, hopefully, oh, it didn't break. Okay. So, so we basically have a case here where, let's say we submit that same one, but instead of it being a response from the backend where we just told it, we're not telling you why we're approving or rejecting this application. In this case, this is the way that HTTP would tell it, I'm rejecting this, and I'm rejecting it on the basis that of the parameter that I got for lead paint. And so basically what we have here is, if we did this response, we basically would say vary lead paint, which means, in this case, the lead paint header that was sent in the request is one of the variables that went into this response. And when you tell it to cache it, you're basically saying that for all of the variables that I'm telling you affect this response, the path and domain name and protocol and other things are assumed to affect this already. This is listing additional things. In this case, what I have here is, by specifying that it varies on that attribute, this would now be cacheable. And now what would happen here is if I put Varnish between this, or any HTTP compliant proxy or CDN, anytime someone submitted an application to the apartment approval API and they said that lead paint :1, this would cause it to reject it without even sending it back to the permit office. Because now the proxy actually understands what ingredients or what variables are going into actually affecting this. And this is somewhat related to working with things like VCL hash in something like Varnish. But the thing that's neat about this is that the backend is actually telling it what it looked at from the request to decide how to compose the response. Now, to take a more realistic example from web applications, and you've probably seen this in millions of traces that you've done through anything like a browser, the same thing is applying to things like accept and accept language and other sorts of variables that might go in as headers for the request. And then by submitting a vary thing here, we actually are telling the cache that you are permitted to send greeting hello as long as you've been asked for something that is English US as a language and application JSON as a response format. And There are other ones that are totally HTTP standard that are included in here that browsers will send. Things like accept encoding change the compression of the response. But at least for an API, often accept is one of the most important things. If you had two different front ends, and one of them wanted XML format and one of them wanted JSON format, for example, this would allow the proxy to actually understand that the response is being altered and the content's being altered, and the cache should depend on these particular headers that are being sent in from the request. And it can be completely arbitrary. You can add whatever headers you want in your request for this, and as long as the backend responds with vary and names those headers, the proxy cache will respect that. However, there are some caveats. Actually, before we get to the caveats, some things to consider as alternatives to this sort of thing for varying responses so that you can get high hit rates and cache more content are doing things like extending VCL hash. So VCL hash is a Varnish specific thing. It basically defines here are all the things that alter the keying for the cache. The downside of VCL hash is that you have to configure it in the actual proxy and in the Varnish configuration rather than allowing the backend to elect whether it cares about these things. For example, if I went back here and I had an API endpoint that requested the current Unix timestamp, the accept language in the request wouldn't affect that because the response is not actually localized. So I'm actually able to dynamically choose from the backend what has altered their response rather than doing a more fixed approach like VCL hash. And you could technically extend VCL hash so that different URLs on your backend are indexed different ways, but it's kind of a dirty solution because you end up having to alter the VCL configuration exactly at the same time as you change backend deployments, whereas the vary headers allow you to basically elect to have the backend announce what is affecting things. There are some limitations and things to consider for this. The headers I was presenting right here are fully standardized for like internationalization usage. Even browsers will give you those, which is also kind of neat because browsers often have extensions and API browsing tools, and you can often change these sorts of accept headers as part of the request that you're sending very easily so that you can see like what does the XML output of this one look like, what does the JSON output of this one look like, and it'll all operate properly. The alternatives that I've seen people use, especially since if you control the client and the server, is you could of course pack these things into the path that you're sending the backend or the query string you're sending the backend. And that's more the direction that Drupal has gone traditionally because some of the vary headers can be a little hard to wrap your head around. Best practices and common mistakes I see around this is a lot of people use vary headers and then only add vary things to responses when they have made an affirmative change to the content in the response. And one thing to keep in mind is that if you look for a particular header in the request and then the absence of that header affects the response, then that also needs to go into vary. And the proxy will actually care about the absence of headers as well if you send it in the vary response. So if you send back, say, if for someone who doesn't send an accept language header, you send back Esperanto, for example, you would still want accept language to be in the response, even though accept language wasn't included in one of the request headers. So whether it's the presence of, the absence of, or the content of a header that is affecting your response, it needs to be included in vary. And also using it for really high cardinality values, like like extremely variant values like user agent, especially if you're proxying any request through and passing that to the backend. This is less likely to affect your front end cases, but anything where it's varying tons and tons every request is basically going to cause your cache to hit poorly because you're basically telling the cache that for every unique value of this header, keep an independent cache item. Oops. Yeah, and then there are some limitations around this. You can store about 200 variants per hash or URL in something like Varnish. So you can kind of go to town for internationalization and different encoding types, but you don't want to necessarily use this as your primary method for distinguishing content. Like you wouldn't want to have something where you sent in what view you wanted or something like that as a header. It's still better to vary different API endpoints by URL. Finally, I wanted to talk about securing the backend via proxy, because one of the architectures that I kind of like is if you can throw your cache right next to your front end, then you can actually get tons of really fast cached responses. So if you deploy something in, say, the US and something in the EU, it can be really neat to throw something like Varnish onto the same boxes as your actual front end. Just because it's a reverse proxy cache doesn't mean it needs to live closer to the back end. This can complicate some of the invalidations, especially if you don't use a CDN with POPs. If you have something like individual Varnish instances, you would need to actually talk to each of them to invalidate them. If you use something like a CDN for this, then usually there's one API that will actually flush all of the caches and purge things globally for a certain cache tag or URL. And that's often a great choice if you have a decoupled front end and you deploy that decoupled front end to multiple geographic locations, because this means fewer round trips across oceans. And then in terms of that, especially if you're locating something like Varnish with the front end instances, you generally have to have some way to tell the back end, this is what this is legitimate traffic from my front end. And I just sort of, this is fairly arbitrary, but it's a pattern that I've seen used pretty effectively. You still want to use something like HTTPS to connect between them, but you can tell Varnish, in this case, to basically inject a header to the backend request that includes a secret. There are far more sophisticated ways of doing this as well, but this works just fine. And then basically what this does is it'll add a header called auth. I would probably choose something like bearer or something maybe more standard, but I wanted to keep this a little short. And then in Drupal, you can basically throw something right at the top of settings.php if you don't have any other configuration of your web server, which you might, and then basically tell it just reject anything that lacks this header or doesn't have the proper value for it. And then that allows you to have a backend that is isolated in a way that you don't accept traffic from anonymous sources right to your backend. So with that, I'll open the floor up for kind of use cases, questions, feedback. Yes.
Yeah. Excuse me. I want to know your feelings on like a localized cache in the browser. I know you were focused a lot on Varnish for the back end, making a request to the back end, saving some time there. So my question would be, what are your feelings on using techniques to just save the user from having to make a response at all? Like, I can give you two examples using something like LRU cache. I'm talking totally decoupled here, where using Express.js, it will make a request, get the request, render it to HTML, and then serve static HTML. So every time it doesn't have to make a request, right? So that's server side. And then on the client side, using a technique like Dexy and using IndexDB to then cache client-side requests as well. So no matter what, the requests are getting cached either way. So not using Varnish necessarily, but just a different technique.
Yeah, there are different ways of working with that. And so if you have a heavyweight kind of like single page application, I assume that's what you kind of mean by that setup, or?
Actually, I'm using Next.
Okay.
So I'm kind of doing a lot more work using Node instead of going that route. But,
okay.
So it's not static.
So IndexDB has, if you use that for your front end, in terms of by front end, I mean literally in the browser, and not just like a node proxy before Drupal. You have some of the challenges of this sort of architecture where, because you basically have the client juggling this concept of okay, check my local cache. If my local cache misses, request it from the backend. After I get the backend response, insert it into my local cache, and also to be able to handle invalidations for that. And there are more reasons, I think, to use that sort of architecture for in-browser cases, because you often have less control over the kind of cache control semantics for HTTP. But if you do use some of these techniques around the vary headers, you can also exploit the HTTP caches within browsers, and they will actually process all of this properly. All the major browsers are aware of vary headers and the headers that are going into the request, and they will actually match up the values of the headers going into the request with the index of the vary headers for the browser cache, and will reuse content that is not stale, that matches all the right parameters for that. Some of the challenges around that are that, of course, you don't have as much control of the other semantics of it, and you can't do any special rules about the content, because basically when you tell it vary here, you're telling it alters the value for the cached item on the basis of anything changing in the header or the presence or absence of the header. So it's a little coarse. So I think that like IndexDB makes a lot of sense if you have some fine-grained cases, or maybe you want to be able to use items in different manipulated formats that aren't supportable by the semantics of HTTP. But one thing I was saying is the browsers are required by the HTTP spec to actually implement all of this, in the sense that they're required to not make the round trip to the backend if they have something that is still within the cache control window and matches the appropriate domain, URL, and headers.
Yeah. What kind of supplementary caching would you want with this? Like, you probably want memcache on Drupal. Would you want any extra caching on the front end?
I would actually consider dropping all of that. Varnish is incredibly effective for caching your API responses and objects, and the actual communication with Varnish versus communicating with memcache is not that different in weight for something like Drupal. They're both of the standard implementations are TCP protocols. It's slightly lighter weight in terms of the number of bytes going over the wire to talk to memcache than to talk to Varnish, but it's not that substantial if you have just regular HTTP between the two of them. And Varnish can handle all of the request volume that you would have for your front end. I would be actually shocked if it were possible to overwhelm it with the sort of architecture that I was showing here, where basically if you have your front ends paired up with Varnish instances, or actually, heck, even if you had the Varnish instance right before your Drupal, it would be really hard to overwhelm it. And also, MySQL databases are so efficient today that I find even for a lot of moderate, traditionally architected Drupal sites, they don't need memcache or Redis. The database actually works pretty well. And if you're ensuring that you're not bootstrapping Drupal very much for your API requests, then that's often good enough. And simpler architectures are often more reliable for all sorts of reasons. Yes?
In my site, I have segmented users. So I have like this, like the vary thing.
Mm-hmm.
But we are using the dynamic page caching from the Akamai. Do you have some thoughts about that? Like, if you use vary or something like that?
So you wouldn't want to use vary for individual user data because the variance, there might be an extremely large number of variants. Is there a different path for each of the users' data?
No, it's just like two cache keys. So it's the anonymous and the logged, like segmented user.
Okay, and then do you bypass the cache for the logged in users?
No, we don't bypass. We just not render server-side rendering some of the blocks and the other page areas.
Okay, so are you using like a server-side include for that?
Yeah.
Okay.
No.
Okay. Sorry, I'm just trying to.
We are just not rendering on the server side. We render on the client. On the browser.
Oh, so it's like.
Two kind of responses.
Okay, so it makes an extra request to the server side for each of those objects?
Yeah.
And then those are customized for the user?
Yeah.
Okay. I mean, what I would probably do is try and vary the path for those. because if it's so I don't know all the internals of how Akamai handles vary. I know that they respect it, but I don't know what the exact limits are. If they have any limits that are similar to something like Varnish, where they basically do the main cache lookup and then they walk through all the variants, you can, if you don't run into breakage from using too many variants, you can often run into performance problems from running too many variants. Like something like Varnish actually tracks all the variants as basically a linked list and just iterates through them until it finds a match. So having more than a couple hundred variants would probably be something I'd advise against. I would advise like having users request their user-specific data via a path that includes content that actually is specific to that user, like their user ID or something. And then that allows the cache to segment out the responses that way. You could, however, do something where you put a vary in for each of those things to verify that they have the right kind of access key. Like that's a neat thing to do, where basically if you require that the user have an active session or something, you could actually say that it varies on the session ID or cookie and for that specific user endpoint. And then if the user requests, if anyone requests that URL, the cache will basically check that their request had an appropriate cookie in it with the right value before sending back the response. And then that way you can actually handle the authorization in the proxy as well. Does that make sense? Like, okay. You can basically make a cache hit contingent on having the right authorization data submitted by the client. Over on the right.
So I hear you on what you were mentioning about even setting extremely short TTLs, and that was earlier, and then more recently you mentioned possibly throwing aside Memcache or Redis or something like that. I'm curious if you had any thoughts about sort of a reverse use case as opposed to allowing Drupal to set the TTLs and waiting for a request to come in, but a use case where maybe you would put Redis between your front end and Drupal, but allow Drupal to push data into Redis with like maybe an indefinite or extremely long TTL.
That's kind of more similar to this case,
okay,
where basically the cache is sort of owned by the front end, but has things manipulated by Drupal. The main reason I discourage that is it creates some close couplings. It's it can be hard to maintain coherency when you have arbitrarily named cache keys and two different systems that are able to access a complex tool like Redis. Like you could even run into things where like Drupal sometimes runs things against Redis, at least with its built-in, with the contrib Redis module. It often does operations on Redis that can be kind of heavyweight, and that can affect the availability and performance of the cache for the front-end purposes. But the main reason I don't like these designs is because like you have to do the whole cache population dance where it's like try to hit the cache. If I miss the cache, request the object. When I get the object, insert it, because you probably have to handle the case where Drupal has failed to populate something that you would expect to be there. Because things can get, like assuming you have any TTLs in Redis, it might flush some items based on LRU or something like that. So you basically have to design your system around missing the cache and responding to cache misses as well as pre-populating it. Also, Varnish can handle a lot of that kind of pre-population stuff for you because since you can do things like the soft purge thing, it can handle the idea of like, okay, this is actually on the border of expiring, but I'm going to give you the stale version, but while I'm giving you the stale version, I'm actually going to fetch the fresh one and replace the cache copy I have. So you don't even have to have the backend think about this case of where do I have to pre-populate things, what's about to expire. But it functions fine, like it'll scale fine, that sort of case. I just think it's more complex to engineer. Yes.
So, two questions. One, I definitely agree with, you can do a lot with Varnish, and the simpler the architecture, the better. So, what are your thoughts on pushing your or relying more on Fastly, since essentially Fastly is Varnish on the edge, getting rid of your reverse proxy and just completely relying on Fastly, because that's kind of like their...
That's actually what Patch does.
Really?
Yeah,
Oh,
it
so
doesn't
you're
actually
like-
have any regular Varnish instances. It actually uses a CDN between their front-end instance and their back-end instance, even though they're actually co-located at the same data center.
In which case, your origin is just kind of just minimized and just it's out there, but there's nothing sitting in front of it.
Now, if you're already using Fastly for your front-end CDN, then I would seriously consider using them for your API proxy as well.
Yeah, okay. And then my second question was, how much of what you went over is completely just applicable to Fastly? Because I know that they're in a lower version of Varnish and probably will be for some time. All of it? Most of it?
So I literally adapted this from working with Fastly,
Oh, wow.
and like not that I collaborated with them on this presentation, but all of this was done on Fastly.
Wow.
And the reason I included the open source version of Varnish as the presentation in here is because I don't want to push a proprietary product.
Yeah.
But Fastly is absolutely fine for all of this.
Wow.
Their version of Varnish will probably never get bumped because they've largely swapped out the runtime, and they are looking at actually. I can't probably disclose all the details, but
Well, I mean, I'm just saying, like, every we're a Fastly customer, Major League Soccer is, I've talked to others, and when you talk to Fastly, they're just like, you get rid of your Varnish and just use us. I want to hear of the case where you can't do that, like when someone is reliant on a Varnish, core
So
feature.
maybe jump in there. We have a case where we still have Varnish on our side.
Yeah.
Because one of the things you need to understand is that Fastly runs Varnish on the edge,
Yeah.
but each edge has probably 10 or 20 Fastly Varnishes running.
Yeah.
So what we ended up with is that the person that in the morning or like warmed the cache, the first 20 requests are all slow because you don't know which of the caches you're hitting.
Yeah.
I don't think that's the case at Fastly. Actually, I don't know whether you're talking about the different. Are you talking about the different pops, or are you talking about the different servers within a pop?
The different servers at the pop.
They now index the requests in a way where they get deterministically hit the same box. I have not seen a case in years on Fastly where different requests miss because of hitting different servers.
So when we solved that with just having a Varnish still in front of the Drupal,
Yeah.
it just does a short caching for a short
Like a
time.
micro cache.
Yeah, that then if multiple pops want to all warm at the same time, your Drupal is not.
You're safe.
Yeah, it's more like a short-term cache situation.
Yeah, this is like the fear, like, oh, maybe we need to still do that because. But
The other thing to look at for Fastly, if you're accessing through multiple pops and you're worried about coherent, and not just coherency, but the hit rate in the sense of once you hit once, you want to hit until it expires. They also have an architecture called Origin Shield, which also has equivalents now at Cloudflare, and Akamai has long had an equivalent of that. And that, so since they now hash the request and send it basically deterministically to the same box or cache within a pop, and then if you stack the pop with an origin shield, that means that as long as you've cached the item at least once, that until it's expired or invalidated, everything will always hit. That's actually how we run the Fastly integration with Pantheon.
Oh, wow. Okay.
So if you hit once, you're going to hit anywhere in the world at least some level of the Varnish cache. We actually used to have that issue though with the multiple servers because we used to have multiple Varnish caches on our edge, and we couldn't guarantee until you had at least 3 requests to a site that you were going to hit again. Yes.
I have a question. If you wanted to compress your API responses, how does that fit in?
You mean like a GZIP or?
Yeah, under HTTPS.
So Varnish can't talk HTTPS. But if you want to make at least open source Varnish can't talk HTTPS. If you wanted to compress it and make it available over HTTPS, I would probably throw a proxy in front of it. I would consider looking at, This is one of the ones that is becoming very popular. It's called H2O. It basically provides HTTP 2, HTTPS, and a bunch of other kind of modern protocol things for talking to a client. I believe it's actually at least partly maintained by some of the people who do some of the Varnish or Fastly stuff. And basically it's designed to fill in all the gaps that Varnish can't do. In the sense of like Varnish talks HTTP 1.0 and 1.1, can't talk HTTPS. This plugs that gap. In terms of cached responses, are you using open source Varnish?
No, Fastly.
Fastly. Okay, so if you do Fastly, you don't have to get this. If you tell Fastly to turn on HTTP 2 for your stuff, or use their H2 endpoints, they are already running a separate proxy in front of Varnish that can handle content encoding and compression separately from the Varnish layer. So their Varnish is derived from Varnish v2, but which has pretty limited ability to juggle compression formats. Like it can pass through compressed data, but it can't really understand it or decompress it or compress it. But if you turn on their HTTP2 stuff, then you're going to have a proxy in front of it that I believe can gzip your stuff dynamically without having to juggle the compressed formats or decompression in Varnish itself. Yes?
Have you given much thought to how like HTTP2 or Quick push support is going to affect these architectures?
So Quick shouldn't have much of effect because that just changes the transport to UDP. I love Quick and I want it to roll out, but I don't. It's the sort of thing where as soon as your client and server support it, it'll just use it and it won't really affect the semantics of the connection very much. H2 push for APIs. The most interesting implementation I've seen of that is on Google's Firebase services. They actually have their stuff set up where when you connect to a database from something like a phone app, they use H2 push to send events down to the client for changes to the data set that it's subscribed to. So that's a neat way to do it. I don't know the best way to H2 push from Drupal though. I haven't actually investigated that enough. But it's not out of this world to like think about the idea of using H2 push as a way to send data down to API clients that they kind of subscribe to.
Yeah, or you could eliminate pull request cycles.
Oh yeah, well I mean, yes, to eliminate polling for sure. That's basically why Google uses it that way, because then the mobile device doesn't have to pull the backend API to get fresh data. This is for their Firebase real-time database and Firestore stuff. They basically can push data to the client whenever the subscribed data changes, and that does use at least Firestore, which is the more modern one, uses H2 push to tell the client that. That's a neat protocol. Yeah, I'm not sure what else to suggest for that. Other than that, you're not off base at all. Anything else? Okay, thank you.